Welcome back to direct and inverse variation, part 2. Recall that we had our direct variation, y equals kx, and we had our inverse variation here, where y equals k divided by x. This was our lead-in to the reciprocal function and ultimately our rational functions. So let's take a look at a problem. Problem 5 tells us that we can have combined variation when we have 3 variables, in fact 3 or more variables. It means we could have combined variation with 4 or 5 variables. We're just going to look at combined variation with 3 variables for right now. So let's consider the general equation if some variable z varies directly with x and inversely with y. Now, if z varies directly with x, then z equals kx. But if it varies inversely with y, then z would equal k over y. So in fact, we could combine our constant of variation into one and write z equals kx over y. And that would be our general equation. So now we're asked for the specific equation for this variation if z is equal to 3 when x is 9 and y is 6. Well, I'm just going to plug these values into my equation. I have 3 for z equals k, x is 9, and y is 6. And I'm going to need to solve here for k. Well, we're going to use my fancy canceling. 9 has 2 factors of 3, and I can cancel one of those factors of 3 with one of these factors of 2. I'm going to multiply this whole equation through by 2 so that I get 6 equals 3k, and I'm going to divide by 3, and I get k is equal to 2. If k equals 2, then my specific equation is going to be z equals 2 x over y, because that tells me that k, my constant of variation, is 2. Lastly, I'm being asked to use this equation to find z when x equals 10 and y equals 4. Now I just need to plug in. I have k is 2, I have 10 is x, and I have 4 for y. So z is 20 divided by 4 is 5. So z is equal to 5. And that completes my combined variation problem. I have one last problem for my direct and inverse variation review video. It says a science club is planning a bus trip to a planetarium. The cost to rent the bus is a flat fee and does not depend on the number of passengers. It will cost $24 per person if 45 people go. How much will it cost per person if 60 people go? Well, the cost is a flat fee, so we can say that the cost to rent the bus is going to be our constant of variation, and the more people go, the less it's going to cost, so we are looking at inverse variation. So I have my cost per person and number of people as x and y. That's equal to my constant of variation, that is the flat fee to rent the bus. So $24 times 45 people is going to equal my constant cost to rent this bus. So a quick check on my calculator tells me that k is equal to 1080. Now I need to find the cost if 60 people are going, and that is just going to be 1080 divided by 60, which, more calculator wizardry, is 18. So it's going to cost me $18 per person if 60 people go. And that's all.